Get a great update from you.
I hope so. Yeah, hey guys, as Peter already mentioned, thanks for the warm introduction. My name is Manuel Sapp. I'm working for Concentric and Zoling since September 2008, so still quite fresh. I'm 30 years old, father, husband, so the default stuff you basically happen during your life. And I want to talk today about Traefik as your Kubernetes Ingress Controller. So up front, what is Traefik? Traefik, the cloud-native edge router. I would probably bet most of you know this already, but whatever. It's obviously hosted on GitHub under MIT license. We just hit about, or over actually, 20,000 stars on GitHub. I just did the new numbers this morning. We are currently above 500 million downloads from the official image from Docker Hub. So quite some action. More than 1,400 looks good to me over GitHub. Half has been called by now, and we have more than 280 people putting their hands dirty on code for Traefik, and yeah, getting stuff fixed, implementing new features, everything you can imagine. The basic question is why Traefik? And the idea behind Traefik was that in regular systems before all of that, you had to rewrite configuration files over and over and over again whenever something changed. And as this was pretty bad, Traefik has been released. But why does this actually happen? So let's have a glimpse at the evolution of software design up front. 1990s and earlier, there were all these big, fat, monolithic applications that you might probably know, but I hope you don't have to work on them anymore, but that can become tricky. They're all super tight coupled. Changes are pretty hard to do, pretty expensive. They take a very long time. So that's pretty bad. About the 2000s, these issues have been recognized, and therefore there was the switch to the traditional service-oriented architecture, which provided everyone with looser coupling, but still it was not what was fun to work with, because it still had its downsides. So like in these days, there are the very, very nice decoupled microservices, but that's what actually brings the problems, because the premise of microservices is everything is living nice together, everything is working out, there is no stress, you are in full control. But in reality, usually something like this happens. So you have a lot of chaos going on, and it's just a mess. You all know it probably. Therefore, sometimes it leads to this. Where's the service? Where's it running? Which IP does it have? Is it up? Is it healthy? All the questions you usually have. And I will not look for Walter, because it will definitely take too long. So this is like what has been. So usually you try to fix this where's the service problem with tools of the trade you all know. Docker, Rancher, Kubernetes, Marathon. Yeah, you all just know them. And that's been basically the base, because that's where Traefik come in. Traefik is like the thing in the middle. You have the internet on the left, and you have the infrastructure on the right, and then you need this magic piece of software in the middle, which provides you with metrics and tracing and logs and all you can think of. So let's dig a bit into this. Let's talk about Traefik with Kubernetes. Traefik with Kubernetes. Up front, Kubernetes a quick recap, because all of you probably know it already, so no need to go into heavy detail. But first, you have the cluster, and the cluster is a group of machines that behaves like one. So you have multiple nodes into this, which is nodes. Nodes on machines in your cluster. They have available resources, and these are just shared inside the cluster and available and can come and go. The next logical element would be a pod. A pod is like the logical group of containers together, so they connect. These pods are basically managed by deployments. You can put up a deployment, and this creates the pods on the nodes, and works for that you have replicas, that it's all spawned, and all of this stuff. On the pods, there is the construct of a service. The service is to get basically the application knowing inside your cluster, so it's up front of a pod. And to add one more problem, there's the Ingress, but this is what Traefik is consuming. An Ingress is an object which is describing how your application should be accessed over the internet. So it has basic questions like, is the host padawan.com? If yes, ask service Yoda. If the header contained the ring, all good, go to photo. And PS, we just don't accept balrogs because they just suck at all. So to go or to work with these ingresses and to consume them, you need the Ingress Controller. And this is where Traefik actually comes in. You got the incoming request. Traefik is able to read the ingresses inside the cluster and therefore knows where to route the requests, and then dispatches it to the corresponding services. But to understand this and to go to really know what's happened, we need to know what are the core concepts and how does this actually work. If we think of this diagram, which I just showed you at the beginning, let's simplify, because this is a little too crowded. You have the internet on the left still. You have just a minor traffic thing in the middle, and just one Docker-based service on the right in the infrastructure. So how does Traefik does this? In Traefik, we have the so-called provider. Docker is a provider, Ranch is a provider, Kubernetes is a provider, everything where we can actually read the configuration out and know where to route the requests. So based on this, we have entry points. Entry points, you can think of something like, what am I listening to? Specific port 80 for default, port 40, 43 for TLS, everything. Do I have certificates? Do I have basic auth? All of this stuff is linked to an entry point in Traefik. On the far right, we have the backend, which is Traefik able to automatically configure. The backend is basically what handles the request. So which is the container, what is the server, load balancing methods, all of this. And right in the middle, because there is still some spare left, we have the front end. The front end is what defines in Traefik how does a request look like. What is the host, what is the path, what might be HTTP headers or whatever. So the front ends are also automatically configured based on, in this example, on the Docker provider, on labels on the containers. So Traefik is able to detect this. So once I have all of these three key parts, we can have a look at the architecture at a glance. We have the incoming HTTP request, which is in the entry point. Then there is looked if there is an entry point for this request. If yes, it goes to the front end, so we can check if there is, for example, a host with the given domain. If yes, it gets checked for the backend, and if there is still a living container, the matching container is called. So in practice, we could have the request with backoffice.domain.com. It goes to port 80. Then it goes to the front end for checking is there something with the given host. Yes, there is a backend with the container IP. Yes, the call is done. So this is how just works in theory and what are the core concepts. So to take this a step away or a step further, there's the herd. And if you think of these herd, you definitely came to the wrong neighborhood. Because when you talk about Kubernetes and you talk about all of this high availability stuff, you usually want to deploy Traefik in a herd. You want to have it clustered. And this is where the current in preview Traefik EE edition comes in. So this is like getting most of my little goof of friends and get them to work. How does this then work in general? Traefik is splitted. So you have requests coming from the internet. Then you have your basic data plane, let's call it like this, which is basically the default Traefik you know, but it's just in a separate plane. And what changes is that there is a control plane beside of that. Why is there the control plane? The control plane controls, obviously, the data plane. And this has the advantage, for example, if you want to have the advanced Let's Encrypt, that you want to have shared Let's Encrypt certificates, or that you just want to call, like once your orchestrator backend, for example, your Kubernetes API, and to get the configuration out of it, instead of having every Traefik instance calling for the Kubernetes API and getting their own configuration and causing load and all of this. And yeah, besides from this is still the same. It goes through the chain, through the entry point, blah, 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 and sometimes, or when it's eventually called to the backend. So what are benefits of this? There comes high availability as by default. You have distributed Let's Encrypt, which has been a highly requested feature within the community. in the parts of Traefik EE, you have encrypted cluster communication, so it's a little more secure. And the next advantage, you have a cluster-wide dashboard. So if you think of the default Traefik dashboard, it just knows about its own stand, but within Traefik EE, this is shared. And you can basically deploy your whole cluster, your whole Traefik EE cluster in one line of command line, and you have everything working and being up, hopefully. Which you can see, the cluster installation is just the base Traefik EE CTL install. And if you want to deploy some config, it orientates itself on how the current TOML file is being written. These are compatible. And as I did just talk a lot and I want a live demo Traefik EE for the first time, it's time to deploy some stuff. What I have done so far, not really that much. Where's my window? There. I have just, for demo purposes, I have spawned the default cluster on Google Kubernetes Engine because it's, for me, the easiest to work with, given the time. And it's really just the basic cluster. It's completely empty. So let's get the credentials first, so we can actually play with it with kubectl. So I get the command, I enter it, and I let it connect. Coolio, done. So I now have access to this cluster, and if we check with kubectl, for example, there's an S missing. There's nothing in it. Yeah, no resources found as expected. So cool. I just said that it's super easy to deploy the cluster, which it really is. I will make it a bit more bright. Is this readable in the back? Okay, cool. As already said, this is really just a one-line install command, Traefik EE install, how you want to name your cluster, your license key, and that you want to disable the dashboard. And you want to tell it, hey, Kubernetes, let's go. So everything you want to do is then hit enter and let it work. What it now does, it's basically a wrapper around common techniques in the Kubernetes ecosystem that you know. For example, Helm. There are some prepackaged Helm packages which are getting called through the Traefik EE CTL, and then it just goes through and creates the whole cluster in about 2 to 3 minutes. So that's what we're going to wait for. What it will deploy by default, it will deploy a cluster of 3 control planes. So you have the control plane high availability by default, and it will deploy 1 data plane per node. So in my case, as I have created a 3 nodes Kubernetes cluster on Google Kubernetes Engine, we will have 3 data planes. So far, so good. Go on. What we can do in the meantime is already check the Google Kubernetes dashboard itself, because it will spawn a load balancer, and we will, of course, need the IP to see something happening. So there we see it's still creating the service endpoints, but the pods are already there, so it should be done in a couple of seconds. In the meantime, yeah, it's still deploying, so it's all right. Ports already open, so that's good. And there are the IPs. So the deployment should soon be done. I need to wait for it because for security reason, the dashboard is obviously secured by the basic authentication by default. And this is the only time, here we go, the only time where you see your username and password and it's not stored. So whenever you will screw, you will need to set the credentials again and a secret and all of that. But what we see, it actually really installed it pretty easily. It deployed it to this IP. It is deployed on the namespace Traefik EE, and it deployed 3 control nodes and 3 data nodes, whereas this control node is the leader. That's elected based on the Raft algorithms you may know from Consul, Docker Swarm, all of this. And we have this 3 data nodes and this 3 control nodes. So I will copy this password because otherwise I will be screwed. And let's open. So it goes, it asks for the credentials, I put it in, and here we go. This is the Traefik EE dashboard, fully done in a couple of minutes. We have just one front end, which is basically the dashboard, and it's matching to a specific amount of backends. What is also known from the default open source version is the metrics tab. The only difference is that these metrics are that they are aggregated over all data planes instead of having every one its own. Then there is finally the cluster tab, which gives me a nice overview about how many control nodes I have and how many data nodes I have. And for all of these, what is the state? Are they ready? Are they down? Are they broken? What is the IP address? And all of that. But the base installation is not that interesting. So let's take it a step further. What you usually do is you write your Traefik toml, which you all know when you have used Traefik already. Oh, this is a little small. Better in the back? Cool. So it's basically just what entry points you have, which parts of the entry points are bound to, what if they use TLS, and that you obviously activate the Kubernetes part, on which Ingress class it should listen. And then something which is cool since Traefik 1.7 is Kubernetes Ingress endpoint, which is basically the option to let really update Traefik, the status field on an Ingress, and give it a proper IP. Why this is important, we will see in a couple of minutes. But at first, I want to deploy this. Config. So everything I need to do is use the command line utility, call it deploy, and give it the path to my toml file. I said toml and didn't type it. So that's all done. My complete cluster is now running with this configuration, as easy as this. So what we should be seeing now is that I have prepared a little whoami service I want to deploy, which is a plain deployment with the whoami image, which just prints you some information about your HTTP request. I have a service, obviously making this available inside, and I have an Ingress to get this accessible with the Ingress class and some stuff we will uncomment later on. And I give it the rule, which is you're accessible on whoami.manualsub.io. You have this empty root path, and it should go to the whoami service on service port 80. So if I just deploy this with the base kubectl apply, it does all of this. So going back into the dashboard, we see that there is the front end already and there is the back end. So if I would have an DNS record set for whoami.manualsub.io to this IP, I could access it by now. But there's the huge if. I don't have an DNS record yet. So if we check the status of the Ingress, we see that Traefik was able to set the IP address of the Google load balancer, which has been spawned automatically, on this Ingress object. And why this is important is because there's this cool thing in the Kubernetes incubator program, which is called external DNS. What external DNS does is it fetches information out of this Ingress object, and goes to the configured DNS provider, in my case DigitalOcean, and creates the needed DNS records on the fly on their own. So I don't even need to bother about setting DNS records on myself, because this can be taken care of. And so if I apply this, he creates it, as we could see. So in a couple seconds, in my DigitalOcean domain dashboard DNS thing, there should be the corresponding DNS entry. And there we go, whoami.manualsub.io to the IP address which has been registered through Traefik from the Google Kubernetes load balancer. So if we now hit whoami.manualsub.io, I see nothing. Maybe the DNS is not done yet. Cool, live debugging, but what should be gone? We just check for, we just get the DNS record that my PC got already known. So we want to have A records. And there we see that there is the correct A record already. So It should be fine, unless I did screw something. Ah, I know what I screwed. So this is not linked to an entry point yet. So we need to tell per annotation that we want to have this service available via HTTP. So we just reapply this. Ah, that was the wrong. So we should see this change in the backend. Here we are. Is it there? It is redirected to HTTP. Why temporary? Ah, because I'm dumb. I did copy the wrong annotation. So this would actually be that he should only redirect, but that's not what we want. We want to have it really attached to this particular entry point. So one more apply. And here we see it's bound to the HTTP entry point, so it should be all right. Why? Ja? Okay, ja, dann setze ich mir einen Host. Ah, there was an old host drin. All right, I'm gone. Bye, guys. Ah! Nice techniques. Okay, so we see it's accessible. Thanks for the hint, by the way. And yeah, we see that we can access the service and it's all good. But having it on plain HTTP is somewhat not what we want to have. So at first we go back into our Atomic file and activate Let's Encrypt. So I'm too dumb to type. What we want to do is I give it an email address. I tell him on which entry point to use the DNS verification, which is the base TLS, the base TLS challenge. I say him on demand true. This is an option to generate certificates on the fly, given what Ingress you have and where to store, but whatever. So I apply and apply also the config. No, that was wrong. There we go. So now Traefik is in itself activated to have it's in ACMA mode, so it can generate certificates. So what we now want to have is we want to have, of course, the Ingress bound to both entry points, and we want to redirect every time to HTTPS. So I apply this as well. That is done. So in a very short period of time, when the Let's Encrypt is done, which will take a couple seconds, this should be fine. Not yet. But what we can do in the meantime is check if everything is fine. So we get the pods. There we see that we have control nodes. By checking the web interface, we know which control node is currently the master or the leader, let's say, which is the control node 0. So we can do the basic kubectl logs -n Traefik EE. And what did I say? It was 0. So we grab this. Oh, it does not really do much. Here we go. Testing certificate renew. So that should actually be all right, because there is no issue. So let's try this again. This is weird. Yeah, but this is for the dashboard. This is something different. It should be all right. This is weird. It's set to on demand. It is on the DNS, on the TLS challenge. What am I missing? One more try, otherwise I'll try something different. Okay, so obviously there's an issue with the on-demand, but this is not a huge issue. What we can do instead is give it the domains it should request certificates for. So that's what we're going to do. But as I'm too dumb to recover the syntax, therefore from my head, I have to check the documentation as well. So this is what we want to do. Within the ACME part, I want to have ACME domains, and I want to have this for wmi.manualsub.io. So let's deploy this configuration again. So what we can do in the meantime is get the logs. So Traefik AECTL logs. There we see that it is some stuff. Yeah, this was deprecated, I know, but this should not be a real deal breaker. We can remove it just to be sure. So this looks okay. Let's check the logs of the master node as well. That was the one, if I remember correct. kubectl logs -n Traefik EE. Here we go. It did test this stuff. It's deprecated, yeah, I know, but it should not be an issue. It's just failing for the dashboard, which is fine as well. So it should work out. One more try. If not, I will screw it for today because then there's something else wrong. But this time it works. So it really is something with the on-demand. I don't know. I will have to dig into it. But it generated the request on the fly, and it's now secured via HTTPS. But what is with high availability if I could not just kill data nodes and have the application still working? So we get the pods again, and let's just kill one of the data nodes, whatever. I need to be quick because otherwise there won't be something seen. But what did I copy paste this time? kubectl. I know. Yeah, too dumb. So, and it's pod. One time screwed and you don't see it. kubectl pod delete. So. What? What is your issue, man? Okay, whatever. Then we do it just from here because I obviously. That was the issue. Thanks. Okay, whatever. We just kill it from here. So there's one pod. Let's kill it. So this data node should be, there's one new already, and if it's slow enough, the other one should at least be red. Go into red. There we go. So this is down, and the application itself should still be accessible, as we can see. And it's also still TLS encrypted, so this is all right. Yeah, so this is working like it should. Whoop-la. By bottle. So because security matters, which we have already seen, Traefik works perfectly fine with Let's Encrypt. It basically supports both challenges, the HTTP challenge for TLS and the DNS challenge in case you want to create Let's Encrypt wildcard certificates. So you can use the DNS challenge to get this done. And I wish we could have talked about, but that would definitely kill time limitations. Other reverse proxy features like rate limiting, health checks, circuit breakers, gRPC, all of this stuff. A lot more HTTP features like custom headers, custom error pages, redirects, proxy protocol, secure, everything. Itself, TLS certificates, Kubernetes secrets, auth forward, everything you can basically think of. In case you want to do tracing or get metrics, we support Zipkin, Jaga, and Prometheus. And lots of other stuff which would definitely kill everything time-wise. Therefore, thank you. Questions?
Hi, how does Traefik itself manage high availability? So if you have 4 nodes, how exactly does it do it?
Traefik itself has an own internal key value store, which where it keeps its state, and it uses the REFT algorithms to share all these updates and everything within the control nodes, and from there it's pushed to the data plane nodes. So it's keeping its own state.
Is it possible to use other methods like BGP?
Not that I know of.
More questions?
So what's the enterprise edition? What do I not get when I leave away this license key?
The distributed high availability for the Let's Encrypt certificates. That's the only difference so far.
No.
Everything else works perfectly fine, but in case you want to have distributed Let's Encrypt, that's when you will have to use it.
Follow-up question, rate limiting, because you just mentioned distributed, do you have rate limiting features, like for cluster rate limiting? Because then it also needs to be...
For what? I didn't...
Like cluster rate limiting, you would need to have something where you sync the state.
Yeah, you set the rate limiting for services, for example, and this is then, of course, cluster-wide for this service.
More questions?
You said that with Traefik EE, there is the cluster-wide Let's Encrypt certs store.
Yes.
Did they remove the key value store from the normal
the key value store support will stay, but you will then, of course, have to manage this on your own, and with the EE, you just install it and you have it by default.
Oh, okay.
And you still have setly these limitations, which is bound to the etcd, that you can't store as many certificates as you want because of the size limitations and all of that. But apart from this, this will stay where it is.
Okay.
More questions? Ah, in the back.
You're quite fast, I didn't see.
Yeah. What can you tell us about the pricing of EE? Because as usual with this, it's all call us.
It's not like this question was unexpected. I don't know the exact price in dollar or euro, but what I can tell is the license model behind it. If we actually go back to the dashboard, it's pretty obvious what it's based on. You get the license, and what is being licensed is the number of control nodes and data planes. So there will be, if I remember correctly, three different packages, where the first package is with one control node and more data nodes, and then it scales like this. And yeah, as more nodes, as more you will got to pay. As mentioned, I don't know the exact prices, but there is no licensing for how many CPU cores will be used or whatever. You really just pay for the amount of nodes. So get big nodes, and you don't need. So it's fine.
More questions? You're on the happy path. Yeah.
Obviously.
You're in time. Many thanks.
Thanks.
Yeah.